Alright, so hello everyone and welcome to the assembly language practice activity here from Exampro. First question. Write into the table below the opcode and the operand parts of the following instruction. Opcode is the command or the instruction, which is load, and the operand is the data being operated or manipulated with, which is 5 here. So let's check the answer. Just want to check the bottom of this. Yeah, so it's 5 and then load. Excellent. Next, write an assembly language program using the instructions given above that adds the content of memory location 7, 8, and 3, storing the answer in memory location 21. Okay, so load 7, add load 8, add 8. Oh, hold on, no need to load 8. Add 8, add 3, and store in memory location 21. Yeah, so let's see if that's the correct answer. So load 7, add 8, add 3, and store 21. Excellent. So this is all correct. And so is this. So let's move on. A single accumulator microprocessor supports the assembly language instructions. Here we go. An example instruction is here. Identify which part is the operand and which is the opcode. Simple, we just did something like this earlier. So opcode is the instruction, opcode, operand. That's right. The accumulator is a general purpose register. What is a register? A small, super fast, a piece of memory in the processor used to store the results or data that is being executed now. So let's see some keywords here. A storage or memory location in the processor. Yeah, I think we got that because we said in the processor and piece of memory. So I guess that counts, yeah. So let's carry on. Using the given assembly language instructions, write an assembly language program that adds together. So, load 12, add 13, store 14. Yep, so that is right. We can just tick all 3 of them. And we got that. So let us carry on. Okay. Shows an incomplete assembly language program. The program decrements the value in R1 in steps of 10 until the value stored in R10 is less than this. So compare R1 with the number 10 and the branch. If this is true, branch less than, if it's not less than. So we need to say if greater than number 10. Then it'll add, minus, what's minus? Subtract SUV maybe? Yeah, SUV. So we're gonna use SUV. So R1 by number 10, and R3 number 1. For example, if I okay. Yeah, I think that's it. Let's see if we got most of it right. The loop start. What's loop start? Where is loop start? Loop. I guess it's just a point we need to add to our vocabulary. So B, loop start. But anyways, we got these 2 bits. So maybe 2 marks. Alright, so next question. Let's use our highlighter. How many different opcodes is the machine potentially capable of supporting? Now, opcodes is the instructions, as we said. So this is the entire section of opcodes. So 1, 2, 3, 4, 5, 6. So 2 power 6 is 64 different opcodes. Indirect addressing, the value stored in the operand is the address of the memory location which contains them. In direct addressing mode, how many memory locations could a processor that use the instruction format use? Okay, so we're taking a look at the operand here. So we're manipulating here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different spots, so 10 power 10. Sorry, 2 power 10 is 1024. So those are our 2 marks, of course. Let's move on. What is meant by the stored program concept? Instructions and data is stored in main memory. The instructions are fetched from main memory, to the processor to be decoded and executed. So let's see if we got that. Instructions are stored in main memory, we got that. By the processor. Fetched, decoded, executed, so I think we got the 2 marks there, but the final mark is programs can be moved in and out of main memory. Okay. Explain the term low-level language. Language that is similar to the instruction set of processor I think that's a reasonable answer. Oh, I think we skipped a question. That's alright. A language that is very similar to or based upon the instruction set of the computer. Okay. Let's carry on. Using the assembly language instruction, let's explain the term opcode. Now, opcode is the instruction or command, which in this case is compare, is to compare the values stored in R2 and R3. Hold on a second. So part B represents the instruction to be executed. Okay. I'm not sure why this wasn't mentioned in the mark scheme, but either way, let's carry on. Okay. Explain what immediate addressing is. So let's quickly do that. Immediate addressing is when the data being called is the value actually that is displayed in the instruction. Let's see. The operand value is part of the instruction. Okay. And next part is write an example of the use of the move assembly function instruction from the table above that uses immediate addressing. So that's pretty simple. Let's open the move address bit, which is, trying to find it here. Here it is. Copy the value specified by operand 2 into register D. So let's do that. Move R2 number 3. Yes, excellent. So we got those 2 marks. There we go. Below is a block of program code written in high-level language. Write a sequence of assembly language instructions that would perform the same operations as the program code above. Write a sequence of assembly language instructions. Okay, so let's do this. So we're going to start with if x is 5. So we're going to use the compare function. Compare is there, right here. Let me highlight it. Compare, that one. So we're going to compare, in this case, x, register x, with the number 5. So compare